Hello folks, and welcome to this episode. It's all about light. Now, I remember when I was young, back in the 70s, when we had the power cuts, and watching out my living room window and checking to see which houses had lights and which hadn't, and how we made light when there was no electricity was fascinating, using tea lamps and hurricane lamps, that sort of thing, candles. So on a boat, obviously people think surely there must be times when you run out of electricity. You can recharge batteries with running your engine, but maybe your engine's out of commission for a time. What do you do then? There are alternatives, and in this day and age we're very lucky because technology has come on a long way. Original tungsten lighting we replaced in the 70s and 80s with fluorescent tubes, which is what this boat was fitted out with in the 90s, and that was standard by then and was more efficient by far. But these days we have LED lighting, and that can be good and it can be bad. Wrongly fitted or incorrectly fitted or cheap LED lighting can actually be a hazard, as I found out. Now, you don't need to use off-the-shelf parts. You can recycle things, and that's what I like to do. It doesn't cost very much for a few components to make them work, and that's all. At the moment I'm doing this little piece to camera, and I've got my little finished article that I'm doing this video on, which is my little video work light, and that's with it off. I just used it a little bit of an upfill on it. It's a bright sunny day at the moment, but by this evening it will get quite dark, and it is actually powerful enough to actually light up my living space while I'm having TV or lunch. And so yeah, it's a useful little device, so I hope you like this video. I've already taken the back off of this little small TV. I've chosen the TV to show you because it's got a very useful screen. The backlight on the screen is nominally 10 volts, and unlike a lot of laptop backlights, it doesn't come out via a ribbon cable to a circuit board. It comes out by two normal wires, which means it's quite easy to connect to. Normally with a laptop you'd be trying to make solder joints to a very small contact on a PCB somewhere, and also trying to determine which bit to connect to. So I've sped it up a bit. I'm just taking the tape off so I can release the circuit board. The circuit board's only attached to the LCD, and that's the part that actually makes the pictures in the TV. So now I'm taking the metal frame apart, easing it apart slowly, and working my way around with the thumbnail. And once you get it going, it's quite easy to take off. So the black bit, that layer there, the top layer, is the LCD. So I just hinge that down and then just pull it out and move everything to one side. Now at this stage I just put the metal frame back. I was quite happy with that, but later I realised that they do actually have a couple of layers of transparent plastic that are effectively lenses, and what they do is they shine the light out towards you, the viewer, instead of spreading the light all around the room. Now for a light source you really don't want that. You also don't want anything in the way that might mess the light, but later on I'll show you how to remove it. These are two little circuit boards. They're very useful. You can get them cheaply on eBay for about £1, and the top one is a voltage booster and the bottom one is a voltage reducer or buck circuit, and you can tell which is which because the input and output capacitors have voltages marked on them, and on the reducer the input side is actually higher than lower, and as I'm showing the bottom, it's actually the top one, the input side, is actually lower than the output side voltage. So this is one we're going to use for this circuit, and this is the little cable, same cable I used for the fan in my earlier video, because I'm going to run it off 5 volts USB. So I need this board to actually boost the 5 volts up to somewhere around 10 volts. That's what the LEDs in this panel require. Laptops tend to have panels with LEDs that run about 30 volts, by the way, so You have to boost them a bit more. So I'm just using crocodile clips. The reason I'm doing this is just to set the circuit up, really make sure everything works. Also, it has that little blue device with a screw terminal. That's a potentiometer, and that will actually adjust what the output voltage is. So I'm going to put it all together with crocodile clips and then get the panel connected all up and just set it up before I actually solder it all together. So I've connected up the input power. Now I'm going to connect up the screen. So I'm cutting the termination off. I'm cutting the terminal off it. Just going to strip the wires back a bit. Believe you me, wire strippers are definitely worth buying. I remember as a teenager using my teeth, but really, your enamel doesn't like that one bit. I quite like hooking things together with crocodile clips because it's quite quick to get things working. And if you're just playing around trying to see what works, you really don't want to be soldering or screwing things together. Now I'm going to put an ammeter in circuit so I can see how much current that's going to be drawn by the light. And I know these panels run at about 10 volts. So if I want the panel to give out 1 watt, it's going to need to run at about 200 milliamps. And that's basically what I'm aiming for. I could run the panel at 2 watts, but then it would only run for half as long. And you don't notice a great difference between 2 watts and 1 watt. 1 watt is generally adequate for most work I do. So this was my initial test, and I actually made a little mistake here. As you can see, the light's quite bright, and I've got my multimeter on the 200 milliamp range, and unfortunately it's off the scale. Now what I failed to do was to set the output voltage at a lower voltage than my 10 volt panel. What happens is the LED basically draws as much power as it can in that situation. Clamps the voltage down to about 12 volts. So this time I actually set the voltage, my little voltmeter on the red one under my hand, to be about 5 volts before I started, and then I dialed up the voltage, and I'm also on a highest amperage range. I'm looking at amps at the moment rather than hundreds of milliamps. So yeah, I want about 0.2 amps. So I got it set up with the voltage set correctly, and now I just actually had to connect it all up, solder it all together, just tinning the wires first before I actually solder some to the board. And the iron I'm using is a little USB iron, soldering iron, and I run that off a little power bank. In fact, it's going to be the same sort of power bank that you will see at the end when I'm running the light. It's a big power bank, running a 5 volt USB. They aren't very powerful irons, but they're okay for this kind of light work, and they work quite well. It saves me having to run my inverter and plug in a standard type soldering iron. The only thing about these soldering irons is that the designers have carefully added a few circuits that actually mean the iron switches off. It's got a vibration sensor inside it, which isn't very good, and that's supposed to determine whether you're using the iron or not and turn off if you put the iron down. And the other thing is they've got a little button where you keep your finger on, and mains hum is supposed to keep that activated so it doesn't turn off if you've got mains hum. But as I don't have any mains on in the boat and I'm running it off a battery pack, there's no mains hum for it to actually pick up. So the iron keeps turning itself off, and worse still, my battery pack is designed to turn off if the load disappears. So I'd opened up the iron and I basically bypassed all the circuitry inside, so it's just a straightforward iron with an LED across it, and it's either on or off whether I plugged it in or unplug it. Now I'm wiring this circuit up, and when I put it all together it didn't work. So I'm jumping the gun a bit here. And this is the input side, and the input side was okay, but in my haste to do the filming and get everything done, I'd crossed over the wires for the actual LED panel. Now, if you notice, I think the positive wire on the LED panel is sitting, which is red, is going into the negative terminal. So when I put it all together it didn't work, and I'll briefly show you how I desoldered it to rewire it correctly, which is kind of a useful example anyway. I struggle a bit with that joint. Normally the iron works a bit better than this. Another useful tool is a solder sucker. Just pulls off any excess solder. Allows you to have another go at the joint. So I'm just connecting the power lead up to the connectors. Here we go, about to plug it in. Oh, what do you know? It's not turning on. Why is it not turning on? Oh, well, I've already explained that. So, this is actually me desoldering. What I'm actually doing there is I'm keeping a finger on the wire, holding the board with my other fingers and thumb, and then putting the iron on the joint and then pulling. I got the wires off. And then once the wire's off, you need to free up the holes again, so just get the old trusty desoldering pump. It's basically spring loaded. You press the plunger down, and then when you press the trigger it releases it quickly and sucks up the solder inside. Sometimes it takes a couple of goes, but as you can see, you can now see the hole again, which means you're back to square one. Thread the wires through and put it together properly this time, Mark. And this time it's all working. As you can see, it's just around about just below the 10 volt mark. Another little piece of speeded up video. Just using hot glue to tack everything down. This panel has a cutout section in the steel back, which lets you connect boards and things like that onto the plastic underneath, which is kind of good. Some of them are actually solid metal, you'd have to put some insulation underneath. Now, I was quite happy with this arrangement. This was my original plan, to make a work light. Just have the little small battery pack and booster pack on the back, USB. And the idea is that the weight of that will actually act as like a stand for a picture frame, and it will stand upright. And that works quite well. And I actually used this setup just like this when I was filming under my sink with the Rust video I've just uploaded recently. And there you go, that's turned on. And it works quite well. But I decided to make something a little bit more professional. I also realised that I'd left the two plastic lenses inside, so to get at those you have to take the metal frame and also a plastic clip frame off, or at least partly off, and then you can lift out the two pieces of light. It's like cellophane, but they're actually quite sophisticated lenses. It's quite clever how they work, and what they're there for is to send the light out towards you, the viewer, when you're watching a TV screen. Obviously what you really want with a light source is you want the light to go out in all directions, a flat light source to illuminate the whole room. So it's worth getting rid of those because they do block out some light and you don't really need the effect they achieve. So once they're out, the idea was to actually put it back in the original case. So I just took off the PCB I didn't need, a couple of leads either side. The green boards on the sides hold the actual switches in, so I didn't want to remove those. And then just place it on the frame, put the outer frame on top, it holds it, and then a bit more speedy up screwdrivering. And then once all the screws were in place, it was time to do something about the power cable. Now I've used a longer lead from something like a keyboard probably, and I'm just stripping the wires off the outside. The cable's being fed through the case, it's the back of the case it's fed through, and it's coming through where the power connector would normally sit. Now the motherboard, which had the power and the audio connectors on, has been removed, so that's just left a hole in the case, so I can just slip this wire through. So I'm trimming off any unneeded wires and insulation, and I've taken the connector away, the screw connector. I'm going to actually solder these in place because it's going to be inside the case and I don't want to have to open it up to actually make joints. So I'm just stripping the wires back, and what I'm going to use is some heat shrink sleeving. I've got some transparent sleeving. I'm going to slip those over the wires first and then solder the wires together and slip the sleeving over. And I missed out a step in the video. I think the camera stopped, but actually what I used was a gas taper for cooking, for setting your hob flames going. I use one of those long handled gas things, and you just use the heat from that flame to actually shrink the tubing down. So I'm just twisting the wire strands back into some kind of shape before I start connecting the wires together. I twisted the two pieces of wires together, power lead onto each positive and negative, to keep it in place before I soldered it. That's transparent insulation I was talking about. And then once it was all soldered together and the heat shrink was in place, I used some more heat glue to actually secure the cable on the back case to make sure it couldn't be took free. And then it was just a question of turning it all round and screwing it all back together. Now, thanks for watching this video. It's been quite a long one. It's quite technical in places, but it's actually made quite a difference to me living on the boat. It's the first thing I started to do when I moved in, was to improve the lighting, and it was quite depressing to begin with. But these lights have made life a lot more pleasant and a lot more normal in terms of how I do things and state of mind. Bright lights actually do help. When I was thinking about narrowboats and moving on, I thought, yellow tungsten type lighting, oil lamp, yellowy kind of homely, warm night light, that's the sort of thing you want on a narrowboat. And having lived on one and been in the deep, bleak, dark winter, I soon realised that no, you don't want dim, gloomy yellow light. What you want is nice, bright daylight. The sort of thing that makes you feel like you're living in a greenhouse rather than living in a dark tunnel. These sort of things, these sort of lights are utilised for people with SAD, to buck their spirits up in the winter when there's not enough daylight hours. And yeah, I reckon in a canal boat they are quite healthy to have. I think they're not only do they make life easier because you can see what you're doing, but they also seem to, yeah, they seem to buck your spirit up a bit. So yeah, I recommend them.